Hello friends, this is Om Prakash Samantray, Assistant Professor in Computer Science and Engineering. We are discussing database management systems. In this video, we will discuss the relational database model. In our previous videos, we have discussed entity relationship model. So, in the relational model, the database is represented as a collection of relations. The relation means it's a tabular structure which consisting of some rows and columns. As a table is a two-dimensional structure, similarly a relation is another name of the table, you can say. There are certain characteristics of relation. A table or a relation is a two-dimensional structure which consisting of rows and columns. Each row of the table is known as a tuple, which represents the single occurrence within the entity set. Means if there is a student table exists, each row or each tuple of the student table or student relation represent one student, or each row of the employee table represent one employee. Similarly, each table column represents an attribute and each column has a distinct name. The intersection of each row and column is known as a field, and the value of the field must be atomic or indivisible or single value. Similarly, the values of each attribute must belong to a particular domain. Domain means the set of permitted values of an attribute, or those values which can be assigned to a particular attribute is known as the domain. And the value of that column or value of that attribute must belong to that particular domain. This rule is called as your domain constraint. The order of the rows and columns is immaterial to the Dbms. That is, even if you change the order of the rows and columns in a table, it will not affect the meaning of the relation. Each table must have an attribute or combination of attributes that uniquely identifies each row. A set of attributes of the table or a relation which uniquely identifies each row in the table is known as a primary key. So every table must have a primary key or some set of attributes which can uniquely identify each tuple in that relation. Keys means set of one or more attributes that determine other attributes. Primary key is the attribute. It may be one attribute or a combination of many attributes that uniquely identifies a, a row in the table or one entity in an entity set. A composite key means when a primary key contains more than one attribute, we call that as composite key, right? And a super key means a set of one or more attributes which uniquely identifies each row. See, the definition of all these keys is same. The only difference is super key has unnecessary or redundant attributes. That is, even if you remove those redundant attributes, you can easily uniquely identify each row in the relation. So super key contains extra attributes, hence when you remove those extra redundant attributes, you get the candidate key. The candidate key is a subset of super key, or you can say minimal super key is known as candidate key. So primary key is a subset of candidate key is a subset of super key. A table may have many super keys or many candidate keys, but it must have only one primary key. There may be many candidate keys on a table, but we select only one candidate key as a primary key. Null values, we come across null values in a table. Most often we try to remove or we try to avoid null values in a table because null value creates more problems while executing the aggregate functions. But if null value is unavoidable, uh, you can place the null value in a relation. But every time we must try to avoid null values for all the attributes. The primary key attribute should not or will not allow the null value. There are three different meanings of null value. These are: the value is unknown, or the value is known but not available, a missing value, or the it's not applicable, right? Date of birth of an attribute. Now, date of birth attribute of a student. We know that uh, every student must have a date of birth, but that if the date of birth attribute contains null value, in that case we can say value is known, value is available, but it is missing, right? Anyway, so null value should be avoided because it creates more problems while executing the aggregate functions and while linking the relational tables. You can see this is the example of two relations, product and vendor. Product code is the primary key of product table, the first table. Vendor code is the primary key of the vendor table. You can see vendor code is also there in the first table. So this is the foreign key here. So this foreign key refers to this primary key. So foreign key is an attribute in one table which refers to primary key of another table. And foreign key, because of the foreign key we achieve referential integrity constraint. Means the value of this foreign key must refer to existing value of the corresponding primary key. That is, if 232 is there in the vendor code in the product table, then 232 must be there in the corresponding primary key. See, 232 is there. If 235 is there in the foreign key, the same 235 must be there in the vendor code of the vendor table. So it must refer to the existing value of the primary key. That is called as your referential integrity constraint, right? In this way also you can represent vendor and product. These are the two relations and these two are interconnected using the foreign key vendor code. In this way also you can represent the relational diagram. We have discussed foreign key, and because of foreign key referential integrity is also possible. Now come to another topic. We have already discussed ER model, then relational model. Now, how to convert that ER model into relational model? We'll discuss the first 7 steps. If you want to convert the ER diagram into relational model, you need to follow these 7 steps. Mapping of the regular entity sets, then mapping the weak entity types, mapping the one-to-one relation, then one-to-many, many-to-many, and mapping the multivariate attributes, and mapping the n-array relationship types. N-array means it's more than the value of n can be if the value of n is 1, that is unary. The value of n is 2, that is binary, like this. The first step is mapping the regular entity types. For the regular entity types, you create a separate relation and include all the simple attributes and identify the primary key. I'll explain it using one example. See, this is one ER diagram. You identify the strong entity sets first: department, employee, project. These are the strong entity sets. Now first you create table for department, project and employee. Include all the simple attributes. Don't include multi-valued and composite attributes. Only include the simple attributes of this entity set and create a table. Now identify the primary keys. As you know, in the ER diagram there is already a symbol used to represent the primary key. Using that you can identify the primary keys. Primary keys are usually underlined, right? Similarly, you can map the weak entity set. In this case, dependent is the weak entity set. You know, weak entity set do not have primary key. That's why you have to associate weak entity set with the strong entity set. In this case, dependent is associated with employee, right? Through the relationship set dependents of dependent and employee. These are interlinked through dependents of. So here the primary key of dependent will be combination of primary key of employee and partial key of the dependent table, because dependent has no primary key, it has only partial key. Name is the partial key of dependent. Now this is associated with primary key of employee, that is SSN. Now SSN plus name will be the primary key of dependent table. So far we have created employee table, department table, project table and dependent table, right? You can see here employee table, department table, project table, dependent table. In the dependent table you can see SSN and name of the dependent combinedly form the primary key of the weak entity set. In the other cases, simply you have included the simple attributes of the entity sets. Now how did you get the other tables? If you follow all these 7 steps, you'll get finally you will get this set of relations. Step 2 is weak entity set, we have already done. Now map the one-to-one relationship. To map the one-to-one relationship, you can one-to-one relationship, either you can insert the primary key of any of the participating entity sets. See, in this ER diagram there is one-to-one relationship set, that is employee manages department. This is 1 to 1. In this case you can either place the primary key of department in employee table or primary key of employee in the department table. But if there is a total participation available, if there is a total participation, then you choose the uh, entity set which is totally participating in the relationship set to hold the foreign key. So in this case department is totally participating in the relationship set, so it must hold the foreign key, that is the primary key of employee is inserted in the department table. With another name you can insert that, so that will be used to represent the one-to-one relationship set. So you can see here in the department table we have inserted MGR SSN, so that is the primary key of the employee entity set, and this one is inserted here as a foreign key. Similarly, start date is the descriptive attribute. So when a relationship exists between the employee and department, then you can find out the value of the start date, that is the descriptive attribute. So descriptive attribute is also inserted in the entity set in which you are inserting the foreign key. So here along with the foreign key you have also inserted the start date, so this become the department table. Now similarly you can also map the one to many. This is the fourth step, one to many relationship. You can see here one to many or many to one, both are same, opposite to each other. So in one to many, this is one to many, employee to dependent. We have already done this in the first step, so we'll consider this one to many from department to employee, and from department to project is also one to many. So for both these relationship sets you can insert the one side primary key of the one side entity set into the many side entity set. So primary key of department can be placed in project. The primary key of department can be placed in employee. So the primary key of the one side, or wherever one is written, you need to identify the entity set near to that one. That is one side, and that is included in the many side entity set. So department Primary key of department is included in employee. Primary key of department is included in project. You can see here. Employee table contains the primary key of department, that is department number. This is the foreign key, and primary key of the department is included here in project, that is the dnum. Don't get confused, the names are changed here because you can put any name here. The domain must be same, but names can be different. Name of the foreign key and name of the primary key can be different, but their domain or data type must be same. So don't get confused if d number is used here in its fullest length, but dno is used for the name of the foreign key. It is also possible here, right? So we have mapped one to many relationship also. Now how to map the many to many? For many to many, you can see here many to many relationship set is there in this ER diagram. Works on is many to many. To represent many to many, you have to create a separate table and include the primary key of both the participating entity sets. In this case, employee and project. Both are the participating entity sets. So primary key of employee and primary key of project. And if any descriptive attribute is there. Now all these are included to create a separate table. So works on is a separate table. You can see here primary key of employee, primary key of project, and the descriptive attribute. So combinedly these two will be the primary key for works on, ESSN and P number. But individually these are the foreign keys. ESSN refers to SSN of employee, P number refers to project number of the project table. So these are individually foreign keys, but combinedly they act as a primary key of the works on table. Now, if any multi-valued attribute is there, for that you have to create a separate table which will include that multi-valued attribute and the primary key of that table. So in this case, location is the multi-valued attribute of department. So you create a separate table with a name. You can name the table according to your requirement, according to your choice. The primary key of the department is if department number, then department number and location will be there in the table. So you can see here department locations, department number and locations. These two are placed in the table. So if there are any other ternary relationships, for ternary relationship also you have to create a separate relation and include all the attributes, all the primary keys of the participating entity sets to form a separate table, right? So if you follow these 7 steps, you can easily convert the ER diagram into relational diagram. So while designing the database, first you have to draw the ER diagram based on the requirements of your system or your project. Then you convert that ER diagram into a relational model using these 7 simple steps. And after converting that into a relational model, you simply implement the DDL statements, data definition language statements of SQL to create the original tables in the database. So with this, we have completed this video session. In the next class, next video, we'll discuss some other topics. Probably I'll start SQL or the structured query language and PLSQL concepts in the next video. Thank you very much.